Hey students, this is our second video on factoring trinomials. Remember, trinomials mean polynomials with three terms. So to factor trinomials, we've already factored trinomials in the other video where the highest power is 1. So we're used to having this highest term just being x squared. And for that one, we were able to use the x method. Well, in this section, we're dealing with where your highest power, x squared, actually has some number multiplied by it. So we're labeling our polynomial ax squared plus bx plus c. Okay, and the way I'm going to teach you this is we're going to factor by grouping. You can actually factor a trinomial by grouping, which is, it takes a while, but it's not too hard of a process once you get used to it. So to factor ax squared plus bx plus c, what you need to do is you're still going to use the x method, but you want to find two numbers that they need to multiply to a times c, and then they need to add to b. So notice I wrote a times c on the top of the x because they need to multiply to a times c, and then I wrote b on the bottom of the x, so they need to add to b. So basically what we're doing there is to get a times c, we're multiplying the first coefficient times the last coefficient, a times c, and then for the bottom number they need to add to b, which is the middle term. Okay? And believe it or not, even after you do all that, you're still not done factoring them. To finish factoring them, then you write bx, which is your middle term, using the factors, and then you factor by grouping. So it's a lot of steps. All right, so we're actually going to be writing the middle term using these two numbers that we get. So instead of writing bx for the middle term, we're going to be writing it as this number times x plus that number times x. And then we're going to have 4 terms, and then we can factor by grouping. So it is a lot of steps, and there are faster ways of doing this. And I will show you a faster way for some problems, but this is the long way, and it's also the way that most people do, because even though it's the longest way, it takes a long time, it's actually probably the easiest way to do it in terms of thinking, because you don't have to be, trying to think of complicated ideas. You just follow the steps and it takes a while. Okay, so let's see an example of this. Okay, so example. We'll actually do quite a few examples. Alright, so example. Factor each trinomial. Factor each trinomial. And for problem number 1, we're going to do 4x squared plus 12x plus 5. Okay, 4x squared plus 12x plus 5. And I'm going to teach you how to do it by grouping. The way the long process I was just talking about at the top. So here, remember, this is our ax squared plus bx plus c. So here a is positive 4, b is positive 12, and c is 5. So we start this out by using the x method. So we make an x with ac on the top. So that's going to be 4 times 5 on the top, and then b on the bottom. So 12 is going to be on the bottom. Or using our colors, 4 times 5 is 20. So we're going to have a 20 on the top of the x. And then the middle term, b, is 12. So we're going to have a 12 on the bottom of the x. Okay? And then we just need to think of two numbers that multiply to 20, but add to 12. And you can just try different numbers. To multiply to 20, you might think of, the first two numbers I think of with 20 are going to be 4 and 5. So if we tried 4 and 5, those do multiply to 20, but 4 plus 5 is 9, so they don't add to 12. So we're going to have to try a couple other numbers. So instead of 4 and 5, let's try some other numbers. How about 2 and 10? So 2 times 10 is 20, but 2 plus 10 is 12. So these actually work. Okay, so those multiply to 20 on the top, and they add to 12 on the bottom. So those are our winning numbers. Those are the ones that we want to keep. All right. So that was this first bit here that I was talking about. So we went ahead and we found two numbers that multiply to a times c and add to b. Now the second part is we need to rewrite bx, which is our middle term, using the factors, and then we factor by grouping. So these new numbers that we got, 2 and 10, we're going to rewrite bx, which here is 12x, using these two numbers. So what's that going to look like? Well, instead of 12x, right, we started with 12x. We're going to split that up now into two terms. So we're going to split up 12x into two terms. So we're going to use these two numbers that we got. So we're going to write it as 2x plus 10x. Okay, and we're allowed to do that because these two numbers add to 12. So we know that 2 plus 10 is 12, so 2x plus 10x is 12x. All right, so you see what we did there? Okay. And then we can just rewrite the rest of our polynomial around it. So remember, the rest of this was 4x squared at the beginning and 5 at the end. Okay, so we have a 4x squared plus 12x plus 5. And now we have 4x squared plus 2x plus 10x plus 5. Okay, so all we did there was we took the original polynomial and we split up the middle term using these two numbers that we got with the x method. All right, and now we're going to factor by grouping. So it is a long process, but now we're ready to, we have a 4-term polynomial, so we can factor by grouping. And I know this is a long process. That's the only problem with this method, is it takes a while, especially for me to explain it. Okay, but to factor this by grouping, we've already done that in other problems. So we put parentheses around the first two terms, and we put parentheses around the last two terms. And then we go ahead and we factor out the GCF from each group. So from the first group, the largest number that goes into both 4 and 2 is 2. And then we also say we have an x in common. So from the first group, we can factor out a 2x. And we're going to be left with 2x plus 1. Because 2x times 2x is 4x squared. And 2x times 1 is 2x. And then from the second group, the GCF here is going to be 5. Because we know the biggest number that goes into both 5 and 10x is 5. So we factor out a 5 from the second group, and we're going to be left with 2x plus 1. And you can check to see if you did that right, because here 5 times 2x is 10x, and then 5 times 1 is 5. So we're good. Okay, and then if you remember when you're factoring by grouping, the whole point of this is that now you're going to have a common factor for the entire expression. So now we see that we have a 2x plus 1 in common for the entire expression. So we can factor out that GCF. Okay, so we factor out 2x plus 1 for the entire expression, and then we're left with whatever I didn't circle, and we put parentheses around that. So we're going to be left with 2x plus 5. Okay? And I'm not usually going to check these, but just with this one, I'm going to go ahead and check it. So how do you check this? You don't have to check it, but I'm going to go ahead and check it with FOIL. So all that means is I just multiply this out using FOIL, and then I make sure I get the original polynomial. Okay, so using FOIL here, the first is going to be 2x times 2x, which is 4x squared. The outer is going to be 2x times 5, which is going to be 10x. The inner is going to be 1 times 2x, which is 2x. And then the last is going to be 1 times 5, which is 5. Okay, and then combining the two middle terms, we get 4x squared plus 12x plus 5. Okay? And we can see that that was actually the original polynomial that we started with in this problem, 4x squared plus 12x plus 5. So that means it does check out. Okay, so that means we factored it correctly. And again, you don't have to check it. I'm just showing you how on this one so you know how to. Okay, but our answer is going to be 2x plus 1 times 2x plus 5. And remember, when you're factoring, the order doesn't matter. So you can also switch the order around if you want to. Okay. All right, so we have factored this by grouping, but as you can see, it takes a long time to explain it. It doesn't take quite as long to do it by hand, but it still is a long process. And the only way that I know of that's quicker is you can do what's called trial and error. So you can try in different numbers until you get numbers that when you multiply them with FOIL, you get this. But we're going to be focusing on this approach because this is the approach that most people use, even though it takes a while. Because it's not really hard, it's just long. Okay, so let's do a later problem. Okay, so I wanted to do a little bit more challenging problem. So for this next one, we're actually going to be doing 4x squared minus 13x plus 9. 4x squared minus 13x plus 9. Okay, so here we've got our ax squared plus bx plus c. And here we can see that a is positive 4, and b is actually going to be negative 13 because it's negative 13x. And then c is going to be positive 9. Okay, and then using the x method, on the top of our x we have ac, so that's going to be 4 times 9. And then on the bottom of the x we have 13, which is our middle term. And then we know that 4 times 9 is 36 from our times tables. And this time I'm doing it without colors, but you can continue to do it in colors if you'd like to. Okay? Now you might be wondering, why did I write positive 13? Well, actually I was being careless. I should have written negative 13 down here on the bottom, because our middle term is actually negative 13. So we do want two numbers that add to negative 13. So mostly what makes this problem harder is we need two numbers that multiply to a positive number, but they add to a negative number. So if they multiply to a positive number, but add to a negative number, that means that both of the numbers have to be negative. Because a negative times a negative is a positive, but a negative plus a negative is a negative. Okay? But that was the only thing that was tricky about it. The rest of it's a lot like the other problem. So if you think about it, what are two numbers that multiply to 36? Well, we could do 6 and 6. If we do negative 6 and negative 6, then we know negative 6 times negative 6 is positive 36 because the minuses cancel. But negative 6 plus negative 6 gives you negative 12. So 6 and 6 does not work. So negative 6 and negative 6 does not work. So we're going to try to think of another couple of numbers that multiply to 36. So how about 9 and 4? So let's try negative 9 and negative 4. So negative 9 times negative 4 is going to be positive 36, which is correct. And then negative 9 plus negative 4 is going to give us negative 13, which is also correct. So these two numbers check out. Okay, so now we have our winning numbers. And then we're going to go ahead and rewrite our middle term, which is negative 13x, in terms of these two numbers. So the middle term is negative 13x. And now we're going to rewrite it as negative 9x minus 4x. So all I did there was I took the middle term, which was negative 13x, that's our bx, and then I rewrote it in terms of these numbers. And then don't forget, we still have our first term, which is 4x squared, and our last term, which is 9. Okay, so we still have a 4x squared at the beginning, and then a 9 at the end. Okay? And then to finish the problem, we need to group the rest of this. So we need a factor by grouping. So we need to group together the first two terms and group together the last two terms. However, that's a little bit tricky here because for the last two terms, we actually have a negative on the third term there. So the tricky thing you have to do is for the last two terms, you have to factor out a negative 1. Okay, so here, for the last two terms, we factor out a minus when the third term is negative. Okay, so factor out a minus when the third term is negative. That's just a little special case that makes the problem a little bit more challenging. So you need to know what to do in that case because it shows up on your homework like this. Okay? So when I say factor out a minus, I mean factor out a minus from your last two terms. Okay? So for grouping this, for the first two terms, we don't have to factor out a minus here. So for the first two terms, we're just going to write it as 4x squared minus 9x. But for the last two terms, for the negative 4x plus 9, we actually need to factor out a minus. So if you factor out a minus from your second group, then you're going to be left with 4x minus 9. Okay? And if you want to make it even better, you can actually factor out a negative 1. A lot of people do that. But I usually do that in the next step. So I'm going to show you the way I usually do it. There are obviously different ways of doing these problems. But you do need to factor out a minus if your third term is negative. Okay. And now we're ready to go ahead and factor by grouping. So for the first group, the GCF here, the only thing that we can pull out is an x. So we're going to factor out an x from the first group, and we're left with 4x minus 9. And then from the second group, because we already factored out the minus, there's not really anything else to factor out. But I do want to have something left here after we factor out the GCF. So instead of writing just a minus, I'm actually going to write a minus 1. Okay, and that's why some people like to say, instead of factoring out a minus, they actually do it all at once, and they factor out a minus 1. Okay, so here instead of just writing a minus, you can actually write a minus 1. Okay, But remember, a minus is the same as -1. Those mean exactly the same thing. Okay, and then now we're almost done here. All we have to do next is, now we have a 4x minus 9 for the entire expression. So we're going to go ahead and factor out the 4x minus 9. So we factor out 4x minus 9 from the whole thing, and then we're left with whatever I didn't circle. So I didn't circle x minus 1, so I put parentheses around x minus 1, and that's what's left. Okay? And you can check this, but I'm lazy, so I'm not going to check it. So this is going to be our answer, 4x minus 9 times x minus 1. Okay? So that one was admittedly a little bit trickier, but hopefully you're good on it now. Now for my next example, I kind of wanted to do one that has a new trick to it. Okay. So for example number 3, we want to factor this trinomial, and this trinomial is 3x cubed plus 10x squared plus 8x. Okay, 3x cubed plus 10x squared plus 8x. Now the thing here that you might not have noticed is normally your highest power is 2, right? So normally it's an x squared and then it's an x, and then there's no variable for the last term. Well here, all the powers are 1 power higher. So the trick with this problem, to make it a lot easier, is there's one extra step at the beginning, which is you have to notice that there's actually a GCF that we can factor out, because all these terms have an x in common. Okay, so what we have to do here is factor out the GCF first. Okay, factor out the GCF first. Okay, so the GCF for this whole polynomial is the smallest power of x that's in common, which is actually just going to be an x. So there's an x in common for all these terms. So we're going to factor out an x from the whole thing, and that's going to decrease all these powers by 1. Okay, so here I'm going to have 3x squared, and then I'll have plus 10x, and then I'll have plus 8. Okay, so that was the main trick on this problem, is noticing that there's actually a GCF you can factor out at the beginning. But after you do that, then the rest of the problem shouldn't be too hard. The reason is this part here, this whole business right here, is in the form ax squared plus bx plus c. So we can go ahead and factor that using the x method and grouping, just like the other problems. Okay, so here we can see a is 3, we see b is 10, and c is 8. Okay, so using the x method, on the top of our x we're going to have a times c, which is going to be 3 times 8, and then on the bottom of our x we have b, which is 10. And then we know that 3 times 8 is 24, so on the top of our x we just have 24. Okay, and we want two numbers that multiply to 24 and then add to 10. Okay, so when I think of 24, the first two numbers I think of for multiplying are going to be 8 and 3. So 8 times 3 is 24, but 8 plus 3 is actually 11. So 8 and 3 don't work. So 8 and 3 did not work, so I'll cross those out. So what are two other numbers that multiply to 24? Well, from my times tables, I know 6 times 4 is 24. So let's try 6 and 4. Well, 6 times 4 is 24, so that's good. And then 6 plus 4 is 10. So now we have the winning numbers. Okay, so the winning numbers are 6 and 4. So now what we're going to do is we're going to go ahead and rewrite our middle term, bx, using these numbers instead. So now we're going to write it as 6x plus 4x. Okay, so we have x. We still have an x out front, and then we still have a 3x squared. But now we're going to go ahead and rewrite this bx, which is 10x, as 6x plus 4x. Okay, so 6x plus 4x. So this whole thing right here is just 10x. Okay? So the whole x method process, the whole reason we do all that is so that we get the winning numbers here, and then so that we can split up the bx, which here is 10x, in terms of those two numbers. Okay? And then here we can go ahead and factor by grouping. So we're going to group together the first two terms and the last two terms. And we still have an x out front. So I'm going to put brackets around the whole thing instead of parentheses. And the reason I'm using brackets is because I want to have parentheses on the inside. So using parentheses, we've got 3x squared plus 6x around the first two terms, and then 4x plus 8 around the last two terms. Okay? So that gives us we're factoring by grouping, but I put brackets around the outside. That way we don't get them confused with the parentheses on the inside. Okay, and then we're going to go ahead and factor out the GCF from each group. So from the first group here, we can see that we have a 3 in common, and we also have an x in common. So we're going to factor out a 3x from the first group, and we'll be left with x plus 2. Now, how did I get x plus 2? Well, 3x times x is 3x squared, and 3x times 2 is 6x. And then from our second group here, with the 4x plus 8, the biggest number that goes into both 4 and 8 is going to be 4. Okay, so we're going to factor out a 4 from the second group, and we'll be left with x plus 2. And then we still have the brackets, and we still have an x out front. Okay? And then now we have a GCF. So we have an x plus 2 in common for this entire expression inside of the brackets. So we can go ahead and circle that and factor that out front. Okay? So we still have an x out front, and then factoring out the x plus 2, we have x plus 2. We factored that out. And then whatever I didn't circle is what's left with parentheses around it. So we're left with a 3x plus 4. Okay? All right. And then we can go ahead and get rid of the brackets now. We don't need them anymore. And that'll give us our final answer. So now we have x times x plus 2 times 3x plus 4. And that's our final answer. And keep in mind that, remember when you're writing your answer, you can switch around the order a little bit, and that's still okay. So for example, you could have rewritten it as x times 3x plus 4 times x plus 2. That would also be acceptable. Because when you're multiplying, the order doesn't matter, so you can switch around the orders of these factors if you need to. Okay? All right, cool. So I think I wanted to do maybe one more example. Okay, so this is going to be our example number 4. Okay, so example number 4. Here we have negative 13x plus 6 plus 6x squared. So the main trick here is to notice that something's wrong right at the beginning. So what's wrong with this polynomial is you can't factor it yet because the highest powers aren't written first. Okay, so that's the trick here, is you need to write the highest powers first. Write the highest powers first. Okay? And that's the same as descending order. Some people know this term. Descending order just means you write the highest powers first. Okay, so what's the highest power that we have here? Well, the highest power would be x squared. So we have to write that one first. So we're going to write the positive 6x squared first. And then what's the next highest power? Well, after the x squared, the next highest power is the x. So we're going to write negative 13x next. And then our last power, our lowest power, is 6. So we write positive 6 at the end. Okay, so it's called descending order because your highest powers are first, so your powers actually descend because they go down as you go from left to right. Okay, but that was the main trick with this problem. The rest of the problem is pretty similar to the other problems we've been dealing with. So once again, using the x method, we want two numbers that multiply to a times c, so that's going to be 6 times 6, and then they add to b, which is going to be negative 13. And we all know that 6 times 6 is 36. Okay, and we actually dealt with these same numbers in an earlier problem. So hopefully you remember that to multiply to a positive and add to a negative, they both have to be negative. And then if we do negative 9 and negative 4, negative 9 times negative 4 is positive 36. But negative 9 plus negative 4 gives you negative 13. Okay, so those are our winning numbers. And then we go ahead and rewrite the middle term, negative 13x, and split it up with these two numbers. Okay, so instead of negative 13x, we're now going to have negative 9x minus 4x. Okay, so those middle two terms are just the same as negative 13x. Okay, and then we can go ahead and factor this by grouping. But to factor this one by grouping, for the first two terms, we can just put parentheses around it. But for the last two terms, because the third term is negative, we actually have to factor out a minus 1 from the second group. So we're going to go ahead and factor out a negative or a negative 1 from the second group. And then what are we left with? Well, if you factor out a negative, you switch the sign of these two terms. So now they're going to be 4x minus 6. Okay, 4x minus 6. Because when you factor out a minus, you switch the sign of those two terms. Okay, and then from here, we have to factor out the GCF from each group. So from our first group here, we see what's the biggest number that goes into both 6 and 9? Well, we all know that 3 goes into both 6 and 9, so we can factor out a 3. And then we also notice we have an x in common here, so we can factor out a 3x. And then what are we left with? Well, 3 times 2 is 6, and x times x is x squared. So we're left with a 2x right here, because 3x times 2x is 6x squared. And then here, we know 3 times negative 3 is negative 9. Okay? And we don't need to have an x there because we already factored out the x out here. Alright, and then over here, what's the largest number that goes into both 4 and 6? Well, 2. right? So 2 goes into both 4 and 6. So we're going to factor out a 2 from the second group. But notice we already have a negative 1 out here. So we're actually going to have negative 1 times 2. And we're going to be left with 2x minus 3. But remember, 1 times any number is the number. So negative 1 times 2 is negative 2. So here we actually have a negative 2 that we factored out. Okay? And now we see that we have a common factor for the whole thing. So the GCF of the entire expression is going to be 2x minus 3. So since that's in common, we can factor that out from the whole expression. So I circled that. So I factor out what I circled. And then I put parentheses around what's left. So I'm left with 3x minus 2. Okay? And that's actually the whole problem. And you can always check it at the end if you want to, but I'm going to be lazy and not check it. Okay, so 2x minus 3 times 3x minus 2. Or on my math lab, they happen to switch the order. So you could have also written it as 3x minus 2 times 2x minus 3. Same difference. Okay, so now that you've seen that one, I think you're going to be good for your homework.